is Hans-Paul Siderius from the Netherlands Enterprise Agency. And as you will see from the title of my presentation, which is more a report itself than a title, it's now, you could say, something different or more down to earth or more in the technical details of eco-design. And I will focus a bit on ICT products because I think that some of the issues there are of relevance for also other discussions within eco-design and labeling. And we can learn from these products and the situation regarding indeed the how we deal with the least life cycle cost standard. And I will quickly show you a couple of slides to give an impression of what Ecodesign and Energy Label have achieved, although that are not the most recent data. Then I will jump into the ICT products and I will make a couple of final more general remarks. This picture should be familiar for most of you because it's from a study from René Kemna for the working plan showing the coverage. And if you look a bit more at the type of products, then you see for lighting there is, I think, quite a good coverage. Heating and cooling, we have room heating, water heating, air conditioners, chillers also there. Yesterday there was the first stakeholder meeting for the review of room heating, space heating and water heating regulations. Motion, motors, pumps, fans, compressors also there. There is, I think, quite a good coverage. And then last, information processing, then it becomes a bit more sparse. We have something on computers, televisions, but there is a lot of products out there. Now, this area is not, you could say, the largest. If you look at the picture, and the slides will be available after the conference. If you look at the picture, information processing is certainly not the largest chunk of energy consumption, but as I will discuss in a couple of minutes, the characteristics of ICT products are, you could say, invading also other sectors, and that's something to keep in mind. What has been achieved, this is also old data estimating an improvement or a saving of 20%, which is a major contribution to the EU goals. And yesterday we heard very preliminary figures for water heaters and boilers, the efficiency improvements. And they were 11% for water heaters and 14% for boilers. So that is really, then you're talking numbers, and that's, I think there was in the meeting, stakeholder meeting yesterday also, I think a general consensus that indeed eco-design and energy labeling have worked in this field, and they will continue to contribute. So how can we now deal with, say, the more ICT products, ICT characteristics? And I've put this figure as a kind of overview. I think there are three main issues. There are technical characteristics, and there we can split them out into energy efficiency, but also the relation with systems. And what we can also do with eco-design is resource efficiency. But there's also some regulatory characteristics, and tomorrow, as Carl said, we will in this conference dive deeper into the review process and to the whole process of setting eco-design and energy labeling measures, and that is certainly something that need to be taken into account when regulating any product, but especially ICT products. And you have, of course, market considerations. And I will talk a little bit more about these issues before then presenting you an alternative way of setting requirements for energy requirements for ICT products. As I said, I focus now on ICT products, but you could also say it's more ICT characteristics, because for instance, you could view a lamp nowadays lighting. You could say it's an ICT product, and not so much as it used to be only a light source. And there are some general trends, and if you take the example of lighting, then you will indeed see that software, the programmability, and the functionality that is defined by the software, you can already buy many lamps on the market that have this characteristic. They're also connected because that enables them to change, for instance, to tune the light color with your smartphone. And the functionality for some products is also that are connected to a network is also dependent on other network connected products. And if you take that to the extreme, then you get the concept of what is called a virtual product. That means that the functions, the real core functions of the product are produced outside the product that is operated by the end user. And the most easy example is the programmable thermostat, where in some of the models the calculations, the computations take place in the cloud, and so the thermostat, you could say, is only the terminal to get access to that functionality. So software and connectivity together, you will get products with multiple functions that can be very easily changed and have a variety of sub-functions. There is a better control of the product, so the product can, for instance, react to changes in load. Note that this also in some cases is seen as a problem, because it also means that things like circumvention and other stuff are also based on these type of characteristics. And the last, also functions can be easily updated by software. And then market characteristics, IC developments very much drive the product development, and it means that with every generation, new chip generation, there is a kind of jump in performance, but also quite necessarily mostly a jump in efficiency, because if the products that we have now today would use the same say watt per unit of performance as they would use 10 years ago, then we would burn our pockets, our chairs, and all things where we put the products on, because they would heat up and they would use much more energy. So these are some of the general characteristics, and now how do they relate to challenges of regulating these products? As it was said, requirements shall aim for the least life cycle cost point in eco-design. However, for many ICT products, there is no relation between efficiency and price. And if there is a relation, it's a spurious relation, as it is called. More efficient products are more expensive, but they're not more expensive because they are more efficient, but they're more expensive because they are newer and have a higher performance. The methodology of eco-design requires insight into future design options. I hope the link works if the slides are put out on the website. But the link shows a short YouTube video with Steve Ballmer, at that time CEO of Microsoft, having an iPhone in his hand and saying, "Who wants to buy an iPhone for $500?" So it shows that even within the industry, there's not kind of consensus, or not all people are really aware and know or acknowledge what are future trends. And for me, for instance, a practical consequences is that multi-tier requirements for ICT products are less suitable, because you have to look far too much into the future, and that is really, really difficult. The process for setting requirements, mandatory or voluntary, that I don't think it makes much difference, takes time, and that is also something that you need to relate to the development. So if you assess data, if you discuss too long, then your data will not be valid any longer. And it's difficult to assess saving potentials of ICT products, because it's difficult to estimate product and market developments. And there's also, you could also argue that maybe some of the improvements also happen without regulatory intervention. So what a regulation really does, that is for these products also more, you could say, more difficult to say. Why regulate ICT products? Still, I think there's a large and increasing volume. There's a limited power consumption per product, so for the individual user, it might not be that interesting to very critically look at the couple of watts that might be saved. But because of the large volume overall for society, it is relevant. The good thing is that improving energy efficiency, if you talk about ICT aspects and characteristics, comes at no or very little material cost. It's in most cases it's a matter of improving software. Of course, that has a cost, but once you have improved the software, the number of products that you apply that software to, that doesn't very much influence the cost. And there is still a variation in efficiency. So now, how should we do that, and how should we regulate ICT products? First of all is define the product group, and that is the first step, but in many cases also a very difficult step, and I will say a bit more about that later. Setting the targets, but not only the targets, also the timing, and the timing is important here. And if there is enough variation, you could also think about using an energy label, and that has some other advantages, and then estimate the savings. So in general, the approach is to use a broad product definition to avoid loopholes and to avoid needing to specify all kind of specific sub-products or allowances or other kinds. Related to that, set relatively relaxed minimum targets to allow for this variety of secondary functions, and then you could use an energy label to identify the most efficient products. Of course, an energy label would indeed only work for, you could say, the larger products where there is something to gain. So that might certainly not be for all. But as indicated here, it has the advantage that the minimum targets do not need not to do the job on their own, but it can be, of course, a combination. This is the product group of ICT, or the definition of ICT products according to the regulation. What is interesting here is that it's the functions of ICT products that are mentioned, and I think these should be used to define the the product groups. And to do that in practice would, I think, require some work, but you could define them. For instance, a television is a display with processing capacity. Maybe also some storage, but these are the two main functions, and you could use that to also look at the further characteristics. Then the minimum efficiency targets and the timeline. If there is a relation between efficiency and price, then of course you can use the life cycle cost or least life cycle cost, although as we've seen in many products there are a lot of assumptions needed, so this there's certainly room for also for negotiation and variation. But if there's no relation, then you can choose more or less between, as we've seen also in other parts of the world, between these kind of three approaches, having kind of modest approach, 20-30% of the market cut off, average efficiency, and what they're doing in Japan, the top runner approach, where you really only keep the 80% or keep the 20% most efficient products. This is based on the products currently on the market, so this also ensures that there will be products that meet the requirements. And then the timing, that's the other part, and there you use the decrease in price, because as we all know, if you want the most fancy television, the fancy phone, you pay quite a lot, and a couple of months later you will find the same product with a much lower price. So there is a price decrease, and you can use that to set the timing. It works like this. At the time of the analysis, if you have a variation in price with an average price P0, and then you cut off by the minimum efficiency performance standards, you could say the lower half, and have a new price, average price P-maps, and you know the curve based on experience data, then the time T1 would be the entry into force date, where the price of the P-maps is equal to the P0. That means that consumers are not, when the stuff comes into force, are not paying more for their products than they would have on average than they would have done at the time of analysis. This is a simple way of expressing it. There will be lots of other issues to take into account, but this is the basic how it could work. Of course, revision of targets is important because as we have, I think, learned from Ecodesign, it's not a hit and run, not a one setting target, time setting the targets, but if you want to achieve your savings, you need a consistent and long-term approach, and that you can also, I think, with the foregoing procedure, you can do it more quicker when there's when there's not so much change in the market, at least in the products, because you can assess the variation at a point in time. You can check the appropriateness of product definition and your efficiency metric, and if this is still more or less valid, then you can repeat the procedure I showed you on the foregoing slide. If one of the two is not valid any longer, so not enough variation, the definition or the metric are not up to date, then you of course should carry out a more elaborate study. Two more points, the energy label classes. If there is variation left, you could also use the energy label. Nowadays the energy label has as additional advantage that there is the product database, so the characteristics of the products will come into the database, will be available not only for consumers, for also for the further review steps. And please note that the energy label regulation allows for labels with less than 7 classes. So if there is variation but not enough for meaningful 7 classes, then you could also use 5 or even 3. Estimate savings, you see here a very simple way of how I would propose to do that. It's clear that with the foregoing procedure, it is kind of difficult to do that in a way you do it for other products, and this is a kind of, you could say, kind of simple estimate, but that might be sufficient. Some final remarks. I think the least life cycle cost methodology is more, even as it's shown in the regulation, is more a guidance than an exact calculation method. And my personal opinion is that we should be happy for that in Europe, because the more exact you make it, the more data you need, and that's the last point here on the screen relates to that, the more there can be debate about the data and how it will work out and so on. So I personally I'm very happy with, you could say, the fuzziness of the procedure, also because, for instance, compared to what the Americans do, the budgets that we have in Europe for the preparatory studies are much less, and you would need indeed at least the amount of money that that DOE spends on this type of research to really make it an exact calculation method. And whether that's worth in the end the outcome, I very much doubt. You can also take into account, and there's I saw there's an article on the table outside. Take into account the cost decrease of technologies through learning curves, but that is more if you really have the least life cycle cost approach. And of course, other variables also influence these decisions. And we discussed yesterday water heaters and boilers, and of course energy prices, affordability. These are all need to be taken into account. And the issue there is the more you push your eco-design targets to certain limits, certain ambitious, the more all these variables and changes and variation will be scrutinized. And so that's also why I am in favor of a kind of sensible combination of minimum efficiency standards and an energy label. I hope this wasn't too technical after Peter's inspiring speech. I don't know whether there's still any room for questions. Ooh, I just hit the time in that was in the agenda, but maybe Niels, 1 or 2 questions. But otherwise, I'm also available here today and tomorrow during the breaks. Thank you very much for your attention.
Thank you very much. And we actually do have a few minutes for questions. So
yeah, thank Arne Rim from Aalborg University in Denmark. Thank you very much. I agree there are more complexity involved with the ICT products, but I didn't get really this with, you mentioned at a certain point this with the multi-tier that was not so relevant, but then somehow you make it relevant in the rest of the presentation. And I was also thinking if you could say a bit about the coupling to the discussion tomorrow about resource efficiency, because I think there can be a lot done making more feasible to repair, change batteries, refurbishment, and so on. So this with the resource efficiency, I think perhaps especially is very important related to ICT products. And then the consumer part also, and the business model, because that will also be something that will change quite significantly, I think, that we will not buy products, perhaps not especially ICT products. They will be leased, I think, to a higher, and that could also be one incentive for the business to have standard that somehow support this. Okay.
Thanks. I will try to answer shortly. The multi-tier, with that I mean that at time of setting the regulation, you do not set only one set of requirements at a certain point in time, but at that time already the next set. And that next set, of course, needs to be further in time than the first. And then the time span, I think, becomes too large to say anything meaningful about what the efficiency can be there. We've seen that with electronics, but also with lamps, in my opinion. That is very difficult, and eco-design also then needs to be a bit at the safe side. You cannot speculate too much, so that would mean that your second tier probably is too weak. So a quicker revision would be a better alternative. Indeed, resource efficiency, and that is maybe the is for ICT products as difficult or as easy as for other products. That's, you could say, the good news. So resource efficiency for washing machines or for a router or a switch, both encounter the same problems, issues regarding if you would like to set requirements on lifetime, for instance, then you need to be able to test that in a short period. And yeah, that's for ICT, is that I think as difficult as for washing machines. So that's why I did not pay much attention to that, because there is not, I don't think there's a very special issue there with ICT products. Although, of course, the time that ICT products are used and then discarded, either second-hand or thrown away, this is, of course, much shorter than with white goods. But the ways to address that are, I think, are in the same direction. And I hope we will hear about more specifically about that in the other presentations.
Okay, we'll take one more question, or maybe two if they're brief.
The questions can be brief, but the answers.
Hi, my name is Elizabeth Reitzenstein from Independent Retail Europe. We represent groups of independent retailers. So we sell all sorts of products. So my question would be, because you did say that there should be on one hand, there should be a very far-reaching definition, so there are no loopholes. But you also said that if the product, maybe I missed that, right? Correct me if I'm wrong. That if the product is too small, there should not be a label. So my question is twofold. How do you define this? Because also a small product can consume a lot of energy, and light bulbs are not very big products, per se. And so the other issue there would be that I believe there should be a difference though between energy labeling and eco-design, because indeed, like, small products can also be consume a lot of energy. So my question is how, your suggestion. So how was this meant? Which products should fall in, which should not? So just some ideas from your side. Thank you.
Thanks for the question, because I now realize that maybe I expressed myself not completely clear. I meant, of course, the differentiation on energy consumption and not on physical size of the products, because indeed we label lamps, and rightly so, and indeed we struggle with where the label we can place the label on the package. So no, the differentiation, I think, should be made based on for eco-design labeling, and maybe resource efficiency can be different, but for eco-design energy labeling on the energy consumption and the savings potential. And as we've seen, as that, for instance, discussions on standby. Standby is, in my opinion, something that is not appropriate for a label. because it's a couple of watts per product, which you can't compare with, say, a label on a fridge. So minimum requirements there for, say, standby only would be sufficient. And but for other products where you take into account the on mode, that situation might be different.
The name is Lancelot Triano from South Africa. You mentioned on the life cycle cost that is not exact. My question is, under what conditions for ICT products at least will it not be useful at all to go the life cycle cost route?
With ICT products and also with other products, what you need to apply, say, the least life cycle cost methodology is a relation between price and efficiency. So, and as I found out for a number of ICT products, that relation does not exist if you take into account, as I said, performance and also the time. And that you can statistically check if you have performance data, price data, and energy data. And you need not, because ICT products are, say, traded worldwide. A television in Europe is not much different from one in Japan and one in the US. So your data need not cover all of the world, but you need to have a kind of consistent set of data, and you can check that whether that is the case. And if there's no relation between efficiency and price, then then of course you can try to apply the least life cycle cost method, but that will not bring you far.